So I'm going to turn it on. We can see all the lights on. And then I'm going to wave my hand. And we hear the owl sounds come out. Welcome to How to Make an OwlBot, the Bird Intimidator. This is part 2, making sound. We left off in part 1 by starting off our prototype building process by using a peer sensor connected to an Arduino Uno in order to provide the functionality for the initial steps of our prototyping process to make this guy to be able to detect motion. And we programmed the functionality within the Arduino chip to detect that motion and then to print out to the serial monitor for us whether or not that motion was detected. So here in step 2, now we want to add the functionality to be able to play an audio file that has owl sounds stored on it, because we're making an OwlBot and we want our owl to make some owl sounds. So the goal for the end of this part of the prototyping process is to detect motion, and when motion is detected, to play owl sounds for us. And in order to do that, we're going to be using an MP3 player, and I'm using the DFRobot brand MP3 player. This is a newer version. This is called the DFPlayer Pro Mini MP3 player, and this is what it looks like. I'll have some close-up images of it shortly, but here's the box that it came in, and you can see there is the part number. It's DFR0768, and I'll leave the links to get yourself one of these if you'd like in the description below. And just so you know, it is an affiliate link, so any purchases made, I suppose that, there's a benefit for us out of that. So anyway, we are going to be using this particular style of MP3 player. There is an older version, an alternative, if you already have one or prefer to use the older version, which is just a little bit cheaper than this one. I think the other one is like $5 or so. This one's about $8 or so. But it is the DFPlayer Mini, and that particular variation uses an SD card in order to store the MP3 file or other audio files onto it. This newer version of the DFRobot DFPlayer MP3 player uses a chip on the board here, and it just directly stores those files onto the board here. These boards are really small. They're like 1 inch by 1 inch. So the form factors on these are quite small and will work perfectly for when we start putting components in our OwlBot later on in the build. What we'll do is we'll jump right into it. You can see here that I've already soldered the pins on my MP3 player. When you get these in the box, they come with the header pins, but they're not soldered on yet. And the header pins that they provide, they kind of give you extra, and we'll have to trim those and then solder them on. So for step 1 of the process, we'll have to trim them to fit, and then for step 2, we'll solder them on. And in step 2, I'll show you a little trick on how to solder header pins on these types of little boards like this. to make it easier to solder them on and to get them straight and make it easier to solder on. It's just a little trick. So we'll jump right into those 2 steps right now. Okay, as I said in part 1 of this build series for the OwlBot project, I'm using the ultimate DIY 3220-point breadboard here to prototype the OwlBot. This was made from a previous project. If you'd like to build your own ultimate DIY 3220-point breadboard, I'll provide all the information to both our website at motbots.com as well as the playlist for the build series for creating this. I'm going to call it TUDIY. That's TUDIY for short, because that'll save me from having to say the ultimate DIY 3220-point breadboard each time I talk about this board. So also, if you don't have this or don't care to make your own TUDIY, then you don't have to have one to be able to try out this project. You can just use any generic 830-point breadboard, as I mentioned in part 1 and on the website, or you can use any other branded 3220-point breadboard. So let's move on to what we're going to be doing for part 2 here. As I said, we're going to be adding the MP3 player to our prototype. In part 1, we set up our power to the breadboard from our 9-volt battery power supply. We also set up the ability for the power to be connected to the Arduino later on. And then we also had our Arduino and made all the connections from our peer sensor to the breadboard and to the Arduino. So now we're going to be adding the MP3 player to our breadboard and making all the necessary connections. As I mentioned, we're using the DFRobot DFPlayer Pro mini MP3 player. Let me get my tweezers. Here's a closer look at it. This is the top side, and this is the bottom side. If I can get it to focus, that's the bottom, that's the top. And like I mentioned, this is the newer version. This is the DFPlayer Pro version, and it stores the audio files directly to the board here on the chip, and all you need to do is just make a connection from the USB Type-C port here and connect it to your computer, and then you can transfer files directly just by dragging and dropping to the driver file of this board on your computer, and that's it. So there's no SD card like the older version of the MP3 player from DFRobot. It's called the DFPlayer Mini. So you can use the DFPlayer Mini if you'd like, but for this project I'm using the DFPlayer Pro. So you can see I've already soldered on the pins to this board. When you receive it in the box, the pins are not pre-soldered for you. At least they weren't for me. So for our first couple of steps, we're going to have to prep this board by trimming the header pins that you receive in the box, because the ones that they give you, they kind of give you extra pins. So we'll have to trim those and to get them to fit on the board, because there's 6 pins on each side of the board here. And then after we trim them, we'll solder them to the board, and that'll be in step 2. So And in step 2, I'll show you a little trick on how to solder these header pins to this board or any other board that you might be using for this project or any other project that you do in the future. And the little trick that I'll show you is a real simple trick in order to get header pins like this to fit on straight and to make everything easier to put in place, or to make it easier to solder everything in place. So I've already pre-recorded the steps to do that. Obviously, as you can see, again, the headers are already on here soldered. So you can check out that pre-recorded video. I'll leave it in the description. And it's a quick little video that shows you those 2 steps in order to get everything set up for this board to place it on our breadboard. So step 1 is trimming the header pins. Step 2 is talking about the trick to solder the header pins onto the board, and then step 3 will be to solder the header pins to the DFPlayer Pro. So right now we'll just pick up on step 4. So after you've watched that video for steps 1 through 3, we're now ready to go to step number 4, where we will be seating the DFPlayer Pro onto the breadboard. So in part 1, we connected the peer sensor to the breadboard and to the power rail, as we can see here, and to the Arduino. Now that we have the DFPlayer Pro ready, we can now seat it onto our breadboard and make all the necessary connections that we need to using some jumper wires. So where I'm deciding to place the DFPlayer Pro on my breadboard, it will be on this side, or this breadboard on this side of on this side of TUDIY. And like I mentioned on the website for step 4, I'm going to be placing the left side pins, the 6 pins on the left side, I'm going to be placing them onto points B6 through B11. And then I'm going to place the right side pins, there's also 6 of them, into points H6 through H11. So I'll go ahead and line them up. Placing the left side pins onto points B6 through B11, and the right side pins through points H6 through H11. And I'll go ahead and bring this up a little closer so we can see a little better. So I have the left side pins on B6 through 11 and the right side pins on H6 through 11. So now that we have the MP3 player set on our breadboard, we can now move on to step 5, where we will be making the connections to the DFPlayer Pro to power. So to make those connections, I'm going to be using a red jumper wire and a black jumper wire. And I'm going to start off by taking the red jumper wire, and I have one here that I have kind of bent in shape in order to try to get it to be placed where I need it to go. So I'm going to take the red jumper wire, and I want to place one side into the VN pin, which in this case, where I have my DFPlayer Pro in place on the breadboard, is going to be at pin, or at point A6. So that's my VN, and I place the other end of the jumper wire on the positive rail of the power supply, the 5-volt supply coming from the Arduino that we set up in part 1 of this prototype build on the breadboard. Next, I'm going to take my black jumper wire. Again, I've just taken a jumper wire, in this case it's black, and I've bent it into shape to get it to go where I need it to. And I'm going to place one end of the jumper wire at the ground pin, or in line with the ground pin on the DFPlayer Pro. And in this case, that's at point A7 on the breadboard, and I placed the other end of that jumper wire on the negative rail of the 5-volt supply that we established in part 1 of this series. So let me show a close-up of this so we can see what's going on here. We have the red jumper wire at VN and the positive supply, and we have the black jumper wire going to the ground pin of the DFPlayer Pro and the other end going to the negative supply. So that's step 5 done. So next is step 6. Step 6, we will be connecting the DFPlayer Pro's RX and TX pins, or its receiving and transmission pins. Now we could connect directly to the TX and RX pins of the Arduino, but this could cause a potential issue. The Arduino Uno only has one serial port, and those are the RX and TX pins that are right here on the board. The Arduino's USB port and the serial port are tied together. So what this means is that when you're trying to compile code and upload it to the Arduino from its USB port here, and you have Arduino's RX and TX pins, its serial port connected to something else. So let's say if we were connecting pins directly to the RX and TX pins on the Arduino board from the RX and TX pins on the DFPlayer Pro, we could run into issues when uploading our code. We'd have to remove the wires on the RX and TX pins here to the serial port each time we'd need to load the code to the Arduino, and then we'd have to replace them back in again each time we would upload code to the Arduino. So we don't want to do that. So in order to get around this this issue is we're going to be tying in to pins 2 and 3 on the Arduino instead, and then we'll put into the code later that we're using pins 2 and 3 as our RX and TX pins. So what we'll do is we'll connect the RX and TX pins coming from the DFPlayer Pro and make the connections from those two pins to pins 2 and 3. So what we're going to do is we're going to connect the RX pin on the DFPlayer Pro using a jumper wire and connecting the other end of the jumper wire to pin 2 on the Arduino. So what we'll do in the code is we'll say that pin 2 will be our TX pin because we need the RX pin from the MP3 player to go to the TX pin that we'll designate as pin 2 later in the code on the Arduino. And similarly, we need to make a connection using jumper wires from the TX pin of the MP3 player and connect it to the RX pin or pin 3, which we will designate as the RX pin and code later on the Arduino. So I'm going to be using an orange and blue jumper wire. These are male-to-male jumper wires, meaning that there's pins on each end of these jumper wires. And I'm going to start by using the blue jumper wire, and I'm going to connect one end of it to point A8. And A8 in my case is the RX pin on the DFPlayer Pro MP3 player. I'm going to take the other end of this blue jumper wire and I'm going to place it into pin 2 of the Arduino, like so. Next, I'm going to take the orange jumper wire and place one end of the jumper wire into pin 3 of the Arduino. So that's the one next to pin 2 here. And I'll take the other end and I'll place it at the TX pin of the DFPlayer Pro, and that's at point A9 on my breadboard. So I'll show you a close-up of what we've got going on so far. We have the blue jumper wire going from the RX pin of the DFPlayer Pro and going to pin 2 of the Arduino. If I can angle it just right, it's upside down, but you can see it's going to pin 2. And then I have the orange jumper wire going from the TX pin of the DFPlayer Pro and the other end going to pin 3 on the Arduino. And again, we'll put into code later that pin 2 will be the TX pin on the Arduino and pin 3 will be the RX pin on the Arduino. And we'll set that all up in code later when we update our code from part 1 of this prototype build for the OwlBot series. So now what we need to do is we need to move on to step 7, and step 7 is loading an MP3 file onto the DFPlayer Pro. So for that step, for step 7, I'm going to refer you to the website where I explain in detail on how to load an MP3 file onto the DFPlayer Pro. And it's very easy to load a file onto the DFPlayer Pro Mini MP3 player. As I mentioned before, all you need is some kind of data transfer cable that has a USB Type-C end and the other end of whatever type USB connection you need to make to your specific computer. And you'll go to whatever website you prefer to go to or whatever sound you prefer to use. I provide the owl sound I'm using for this project on the website. I'll leave a description to everything you need down below. But whatever file you're going to be using, I'm using an MP3 file. You can use different audio files, and I'll leave a link to DFRobot's site for this DFPlayer Pro Mini MP3 player, and it'll tell you what types of files you can use. But I'm using an MP3 file that has owl sounds on it that I found the file at freesound.org. All that information will be left in the description and on the website. But all you need to do is have your MP3 file in your folder on your computer and have the folder of the driver file for the MP3 player, and basically you just drag and drop that file into the file for the DFPlayer Pro, and that's it. That file should be ready to go to use. You can just unplug the USB cable to the MP3 player and it's got the file set in here and it's ready to go. And then later in the process of setting up the prototype for sound for step 2, the current step that we're on in this build series, we'll put into the code the functionality to play that file using Arduino for when motion is detected by the peer sensor. So assuming that you've gone to the website and followed the instruction for step 7 to upload the file to the MP3 player, and you've already got that set up, we're now moving to step 8, where we're going to connect the speakers to the DFPlayer Pro. I'm using 2 3-watt 8-ohm speakers. They're just a couple of basic speakers. And I'm using 2 because the MP3 Player Pro has the ability to output to 2 speakers, unlike the older version of the MP3 player from DFRobot, the DFPlayer Mini. I only had capability of outputting to 1 speaker, I believe. So I'm using 2 speakers for this project. And what we're going to do is we're going to make connections using jumper wires to these speakers, because these speakers have these JST connectors on them. And I've already got the jumper wires installed in each of these. But my speakers have these JST connectors on them. And for prototyping purposes, I'm just going to take an orange and a yellow jumper wire, and these are male-to-male in jumper wires, and I'm going to just shove those pins into the holes of the JST connector on these speakers. just to make an easy connection to the breadboard. That's all I'm going to do. So what I'm going to do is I'm going to take an orange jumper wire and place it into the hole connecting to the red wire of the speaker. That'll be my positive. And I'll take a yellow jumper wire and place it into the hole connecting it to the black wire of the speaker, and that's considered my negative. And I've already done the same for this speaker as well. I have the orange jumper wire going to the red wire and the yellow jumper wire going to the black wire. So I have both of my speakers ready to connect to the DFPlayer Pro. I'll set that one aside. And what we'll do is we'll take the other ends of the jumper wires, the orange and the yellow wires, and we'll begin making our connections for the speakers to the MP3 player. So what I'm going to do is I'm going to take the other end of the orange jumper wire for this speaker. It's connected to the red wire, remember, and I'm going to connect it to the R plus pin on the MP3 player. And for me, that is going to be pin I9 in my case, where based on how I've placed the MP3 player on the breadboard. So I have the orange jumper wire coming from this speaker. It's connected to the red wire of the speaker, and it's going to the R plus pin on the DFPlayer Pro, and it's going into pin point I9 in my case. Now I'm going to take the other end of the yellow jumper wire, and remember, we have it connected to the black wire on the speaker. I'm going to take the other end and connect it to the R negative pin on the MP3 player, and that happens to be at point I8. So if I bring it closer, I can show you what we have so far is that here's the speaker, here's the red and black wire. The red wire goes to the orange jumper wire, and the orange jumper wire is going to the R plus pin, and then the yellow jumper wire is connected to the black wire, and the other end is connected to the R minus pin on the MP3 player. So now we're just going to repeat this process for the second speaker, and here that is. So I'm going to take the orange jumper wire for this speaker. One end is connected to the red wire of the speaker. I'm going to take the other end of the orange jumper wire, and I'm going to place it at the L plus pin of the DFPlayer Pro Mini MP3 player, and that happens to be for pin 11, or excuse me, at point I11 on my breadboard. And I'm going to take the yellow jumper wire where we connected one end to the black wire of the speaker, and I'm going to take the other end of that yellow jumper wire and place it at the L minus pin of the DFPlayer Pro, and that is the L minus pin, and that happens to be at point I10 on my breadboard. So if I bring it closer, we can see that, oops, this speaker here that we just connected is connected to points L plus and L minus. I have the orange jumper wire, which is connected to the red wire of the speaker, and the other end of that orange jumper wire is at pin L plus. And we have the yellow jumper wire, which one end is connected to the black wire of the speaker, and the other end of the yellow jumper wire is connected at the L minus pin of the DFPlayer Pro Mini MP3 player. So we have both of our speakers connected to the DFPlayer Pro Mini MP3 player, and that is it for step 8. Okay, once you've already uploaded the MP3 file onto the DFPlayer Pro MP3 player and have already connected the speakers to the OwlBot prototype on the breadboard, we're now ready to move on to programming the Arduino or updating the code in for the Arduino that we did from part 1 of this OwlBot build series. I already have the website up on my browser here, and I'm at the page for how to make an OwlBot for part 2. And what I want to do is I want to scroll down to the table of contents here and go to programming the Arduino to make sound, and that'll take me down here where we can see the code here. And what I want to do is, instead of typing all this by hand, I would just want to copy it by pressing the copy button. And then I'm going to go back to the Arduino IDE here. You can see that I have it up here on the screen already. I've already saved it as OwlBot Part 2. You can save it however you like, but in keeping with consistency on this build series, I'm going to have mine code saved in this format like this. So what I'm going to do is I'm going to select all this and delete it, and I'm just going to paste the code that I copied from the site right into the page here. And then now what I'm going to do is I'm just going to save, and it's ready to go. So once I connect my Arduino to my computer, I can upload it to the Arduino, and then we can move on to the next step. So what we can do now is just kind of go over the code here, the new stuff that's in here. So what we've added to our code from part 1 of the build of the OwlBot and prototyping the OwlBot, we've added this new include here, the include DFRobot df1201s.h, and this is just for the DFRobot DFPlayer Pro Mini MP3 player. It's the library for it. So our MP3 module has its own library that we need to include in our code. The next thing that I've added here are these two variables here for the RX and TX, or the receiver and transmission pins on the Arduino. So the RX here is assigned to pin 3 on the Arduino. So we can see here it says this is what we'll designate as the RX pin on the Arduino. This is not the RX pin for the DFPlayer Pro. And similarly, this TX variable that we've assigned to pin 2 here, this is what we'll designate as the TX pin on the Arduino, not the MP3 player. So next we've created a new serial object here, the software effects serial here. We're using software serial, and we're passing in the two arguments for the variables we just created up here above, the RX and TX variables. So what we're doing is we're creating an object for our sound effects serial, which is saying which pins to use for receiving and transmission. So basically this is what's used to communicate with the DFPlayer Pro module that we have in our current prototype setup. So moving along, we have an instance of an object here using the DFRobot object here, which we've named Sound Effects Player. And we'll use the Sound Effects Player object when referring to the Sound Effects Player or the MP3 player. Now we want to look down into the setup, and here we can see that we've added a couple of more pin modes here, one for the RX and one for the TX, the two variables we created up here. And we're saying that the RX will be an input and the TX will be an output. So for the RX, we said this is the RX pin on the Arduino. That's our receiving pin for the Arduino, so it needs to be an input because it's receiving information. And then for the pin mode for the TX, this is our transmission pin for the Arduino, and it needs to be an output pin because it's transmitting data out from the Arduino. looking at the serial.begin or the serial setup that we have here, previously we had a baud rate here for 9600, which is the typical baud rate that you would use for most instances. But I found that when I initially tried to use the MP3 player and look for output to the serial monitor using a 9600 baud rate, I was getting gibberish printed to the serial monitor. So I had to look up on DFRobot's website for the DFPlayer Pro mini MP3 player to see if I could find if there was a specific baud rate that I needed to use. And I saw in some of their example code on their website that they were using a baud rate of 115/200. So I added that in my own code and ran it again, and I was able to get the output that I was looking for to the serial monitor. So that's why I'm using this baud rate of 115/200 in order to be able to use the serial monitor for debugging purposes. Moving along, we can see that we have an instance of the sound effects serial that we created up here, where we're also using the same baud rate value for it. And this is just for setting up the serial for sound effects serial. And then here we can see that we are basically just telling the sound effects player to use the sound effects serial. So remember that the sound effects serial said which pins to use for the transmission or TX pin and receiving for the RX pin for the Arduino. So the sound effects player refers to the MP3 player. So what we're really saying is that we want the MP3 player to listen for signals from the Arduino serial port that we made from pins 2 and 3. So pin 2 on the Arduino is the TX pin, and pin 3 on the Arduino is the RX pin. So now if we look down here, we're just doing the setup for the player itself, the MP3 player. So these are just some built-in functions from the library, from this library here. And remember, we created this object here called Sound Effects Player from that library. And here we're just doing an initial setup using the built-in functions from the library that we're using. So we're saying here sound effects player .set vol, which is just us setting the volume for the MP3 player. And here I've used a value of 30, and I think the range goes from 0 to 30, where 0 is the lowest volume setting and 30 is the highest volume setting. Here we're calling the switch function, and we're basically saying that we want the sound effects player to be in music mode. Next, I have the set prompt set to false, and what this is that when you initially turn on the MP3 player, there's a voice prompt that comes on, and I didn't want to have that play when the MP3 player is powered on. So in order to silence the voice prompt at the start, we'll just put the set prompt to false. And then here I have a delay for 2 seconds or 2000 milliseconds in order to allow for everything to calibrate. And then here we're just setting the play mode for the sound effects player to all cycle, or we want it to repeat all. So in this case, we just have one file, the Owl Sounds MP3 file that we loaded to the MP3 player, and it's just going to allow that to continually repeat. If you had more than one file, it would just repeat everything in your MP3 player. So moving on to inside the loop. So before we get into the loop, I'm going to go back up here to the top of the code so we can look at the variables that we initiated back in part 1 of the OwlBot project. And here we see that in part 1, we created this motion status variable, and we initialized it to be low, and we also created this peer state variable, also initializing it to be low. The motion status was for our current motion status or signal pin reading. It can either be low or high, and again, we're initializing it to be low. And the peer state variable is the state of the peer signal pin. So it's either high or low, and initially we set it to low. So I just wanted to go over those two real quick in order to refresh our memory on those two variables that we created in part 1. And going back down to the loop, starting at the motion status variable here, we're now setting it equal to a digital read, meaning that we're wanting to read the digital pin of the peer sensor here, and that was pin 12 on the Arduino. And then if that motion status is high, or it's reading a signal coming from that digital pin, then we want to go in this if statement. And here it's asking if the peer state is low, we want to go in here, and we initialize the peer state to be low. So initially when the for loop is, or when the code enters the for loop, and if there's motion being detected by the pin 12, then it's going to go in this if statement here because motion status is high. And then because we initialized peer state to be low, it will go into this if statement. It's going to print out that motion was detected to the serial monitor, and then we're going to change the state of peer state to high. And then here we have the if statement asking whether or not the sound effects player is playing. So here it says if the sound effects player is not playing, that's what this little exclamation mark here is for. So if the sound effects player is not playing, is basically what it's saying, then we want to start playing the owl sounds from the MP3 player. If the motion status was still low, meaning that there wasn't any motion detected, it wouldn't go in this if statement. So it would go to this else statement. And here, if that peer state was high, it would tell us that no motion was detected, set the peer state to low, and then if the sound effects player is playing, then we want to pause the owl sound. So this would go to the pause owl function, which we created this function we'll take a look at in just a minute. And we also create this play owl function, which we will look at next. So as I stated, if the code were to reach this part of the code where it wants to play the owl sounds, if the sound effects player isn't playing, it would jump down to this play owl function here, and this is a function that we create ourselves, and I've named it play owl. And in here we have a variable called file num, and here we're getting the current file number within the MP3 player, and we're setting it to the variable file num. Each file in the MP3 player will have its own value. For this project, we're only using one file, and that's the owl sound file that we loaded onto the MP3 player from before. As I mentioned earlier, you could have other files that play other sounds on your MP3 player module. So here we're again using one of the built-in functions for the DFRobot library, and here we have an argument of 1, and what we're saying here is that we want to play the first file on the MP3 player, and the numbers are arranged according to the sequence of files copied onto the UDisk on the MP3 player module. And then here we want to set the play time to 0, and what this does is it starts the file 0 seconds in or at the very beginning, and then we want to start playing the sound effects by using the built-in function start. So now we come to this for loop here, and this is just an easier way for me to have the owl sounds play for about 10 seconds. So the for loop saying that initially this I variable is set equal to 10, and then if I is greater than 0, then each time we go into this for loop, we want to decrement this value of I. And what we want to do is we want to print out to the serial monitor the value of I. So initially it's going to print out the value of 10 because we initialized I to be 10. We want to wait for 1 second, and then it'll jump back up here to the for loop after it's already decremented the value of I by 1. So now after the first loop, now we're at the value of 9. It'll print out 9 to the serial monitor, wait a second, go back up to the beginning after decrementing the value of I. So now the value of I is 8. It'll print out the value of 8 to the serial monitor, wait a second, and it'll keep doing this until the value of I is no longer greater than 0. So once I is at 0, it will leave this for loop, and this process takes approximately 10 seconds. So basically we're just buying some time here, approximately 10 seconds, as I said, until we get down to this line here where we're calling the pause owl function. And the pause owl function here is a function that we make. I've called it pause owl. And in here we're telling the sound effects player that we want to pause the player. So that's basically all that we've added to our previous code from part 1 of the OwlBot project. This is the functionality that we have now to be able to use the MP3 player that we've added to our prototype. So next what we need to do is just compile this code and upload it to the Arduino. Okay, in discussing about compiling and uploading the code to the Arduino, once we plug in the Arduino to our computer, we of course need to make sure that we go up to Tools. I know you can't see it on the screen right now, but we go up to Tools and make sure that we go down to Board and Arduino AVR boards, and make sure that you check the board that you are using. In this case, for this project, we're using the Arduino Uno. And then again, I go up to Tools. Again, I'm sorry you can't see it on your screen right now, but I go up to Tools, and then this drop-down menu comes down, and then the next we would need to go to Port, and then choose the port where your Arduino is located at. And in this case, this is my port for the Arduino Uno, and I make sure I check that one. And you can see down here at the bottom that it shows that the Arduino Uno is showing up in the IDE. I'm using a MacBook Pro to compile and upload the code right now, and you may come into a couple of problems if you've never compiled or uploaded code from the Arduino IDE to an Arduino before. You might run into a couple of errors, a couple of different errors. So the first error I want to discuss is an error that you might receive, and I pull up my browser, you might see an error that says something about a bad CPU in Executable. And right now I'm at Arduino's website, and I searched this specific error that I had received, and what it may be is these newer Apple MacBook computers that use the Apple Silicon instead of the Intel CPUs. You may need to install what's called Rosetta onto your computer, and right here on this page on the Arduino website, it gives you the instructions, in this case, to manually install Rosetta. So all you need to do is just open your terminal, and then in your terminal you would just need to type in this software update -- install - Rosetta. In my case, I've already installed this on my MacBook Pro, so that's already been done. But all you would do is you just type it into your terminal window and then press enter, and then you'd have to accept the license agreement with Apple. So basically you'd just type in the letter A and hit enter, and then wait for it to install and finish, and then you just close out your terminal window, and then that should fix that particular error. But you may also run into another error, as I did, because we're using the DFRobot DFPlayer Pro Mini MP3 player for this project. We're having to include the DFRobot library into our code, and if that library is not pre-installed on or into the Arduino IDE, we may receive an error such as this one. I did install it before making this video, but I also removed it in order to show you what the error may show if you have not installed it, and then I'll show you how to install this particular library. So I'm going to press the upload error here to upload the code to the Arduino. And then you can see I get this error, this compilation error that says there's no such file or directory for this particular library that we're trying to use here for the DFRobot library. So in order to install it, the easiest way is just to go right here to where it looks like these stack of books here. And if we click on it, we can see that we're in the library manager. And in this window here, you can see I already have the library typed in here. So all you do is just type in this window here, DFRobot underscore, and we're wanting the DF121S. So I type in DF121S, and we can see it show up right here. This is the library that we want, this DFRobot underscore DF121S. So all you have to do is just press install. It'll install it. And then once that's done, I'm going to go ahead and press this book icon again to get that out of the way. And then I'll press the upload arrow again. We see that it's compiling and uploading to the Arduino, and it's done uploading. So now I don't have an error. So if you ended up receiving that particular error, so if you ended up receiving those particular errors, I hope that helped you out. And then now we can continue on with the rest of this project. Okay, I have a little bit closer up shot of everything right here. We just uploaded the code to the Arduino, and right now I've plugged into the power from the 9-volt battery supply, and I haven't turned it on yet because while I'm sitting here trying to talk, it would keep going off playing owl sounds. But I'm going to hook up the power to it. I have the peer sensor sitting here, and I'll wave my hand in front of it once I turn it on. That way we can hear what it sounds like when the owl sounds come out of the speakers here from the MP3 player, and we can test out to see if everything works as we want it to. So I'm going to turn it on. We can see all the lights on, and then I'm going to wave my hand. And we hear the owl sounds come out. Now, I don't know if you can tell on the camera, but the audio coming out of the speakers sounds a little bit harsh, a little bit rough. Sometimes you can hear kind of a crackling or a popping sound. It doesn't show up too well right now, but there's a way that we can improve the sound quality on the DFPlayer Pro, and we're going to take that step next. Okay, now that we've got our code and we had everything running and we've tested it out and everything seems fine and dandy, our owl sounds are playing on the speakers, we may realize that there are some sounds coming from our speakers, maybe some crackling sounds or vibrations or something, and that can be kind of an annoyance. But for this part, I'm trying to move my light around here to get some of the glare out of the way. But for this part, we're going to try to improve the sound quality of the DFPlayer Pro. And I've actually already set up everything prior to starting to record here. Can you notice any differences in the board? Anything different on the breadboard? Maybe if I can zoom in here a little bit and get my trusty orange pointer here. What we can do to try to alleviate some of that sound distortion in the speakers is that we can add a 1K ohm or 1000 ohm resistor. That's a brown, black, red stripe resistor. I have one right here. And we can set one end of its terminals at the RX pin and then connect the blue wire that we had coming from pin 2 of the Arduino to the RX pin. I've just shifted it to the other terminal of the resistor. What I'm going to do is I'm going to reset the camera so I can bring you in a little bit closer, and then I'll explain it a little bit better. Okay, I have the camera up a little bit closer now, and like I said, in order to reduce some of the noise to the speakers, I've added a 1K ohm resistor here. Again, that's brown, black, red. And where we used to have this blue wire, this blue jumper wire that's connected to pin 2 of the Arduino, it used to run to the RX pin, and you can't quite see it in the camera, but right here where this lead is of the resistor, that blue jumper wire used to go to this point on the breadboard, which runs in line with the RX pin. I'll just move this orange jumper out of the way. But where the resistor is now is where the blue jumper wire used to be, right at the RX pin. Now we've moved that blue jumper wire to a point up on the breadboard here that's not in line with anything else. I happen to have this blue jumper wire at point B2, and I have, as I said, the resistor, one of the resistor leads now at the point that's in line with the RX pin of the DFPlayer Pro, and that happens to be at point A8, and the other end of the resistor, or its other lead, is in line with this blue jumper wire now at A2, at point A2. So having this 1K ohm resistor here will hopefully reduce some of that noise. I will play a couple of clips next that will show the differences in sound quality. The first being what it sounds like as we had it before we added the resistor, and then what it sounds like once I've inserted the resistor at the RX pin of the DFPlayer Pro in line with the blue jumper wire that goes to pin 2. So we'll listen to the different sound qualities real quick, and if I just happen to arbitrarily choose a 1K ohm resistor, I've noticed that online most images and information that I've found about resistor sizes place it to put in place in line with the RX pin of these DFPlayer Pros is usually a value of 1K ohm or around 1K ohm, but you could test out yourself different resistor values. You can go smaller than 1K ohm. That's most likely going to not help out as much as this 1K ohm resistor would be, a value less than it. But you can try higher values of resistances, maybe such as you can try a 10K ohm resistor and see how that sounds. I would just play around with it. I haven't personally done it. I just stuck with the 1K ohm. But you will tell in the 2 comparison video clips that I will share with next that there's an obvious reverberation or noise within the speakers when there's no resistor, and there is a little bit better quality in the sound with the resistor, but there still is some noise coming from the speakers even though I have a 1K ohm resistor, but it sounds a little bit better. But as I said, you can play around with it as much as you like and just try it out. I really encourage you to play around with it and see what works best for what you're looking for out of this project. So we'll listen to those 2 audio clips in comparison of the sounds coming from the speakers with and without the resistor. And that will finish us up for part 2 of how to make an OwlBot, the Bird Intimidator. Again, this was part 2, making sounds. In part 3, what we'll do is we'll end up adding some flashing red LED eyes to our OwlBot prototype so that when the peer sensor senses motion, the OwlBot will start playing sounds and also start flashing its red LED eyes. Oh, and I just noticed we mustn't forget to put the orange jumper wire back, and that just goes to pin TX to the DFPlayer Pro, and at the other end goes to pin 3 of the Arduino. Just like that. Okay, this has been How to Make an OwlBot, the Bird Intimidator, Part 2, Making Sounds. Next time, we're going to be adding the OwlBot's flashing red LED eyes. So by the end of the next part in this series, we'll have the ability for motion sensing through our peer sensor, making owl sounds from our DFPlayer Pro Mini MP3 player and the 2 speakers that we've attached to it. And then we'll have the OwlBot's red blinking LED eyes. I want to thank you for joining me for this fun project. I hope you have enjoyed it as much as I have, and I will be seeing you in part 3 of the OwlBot project. Remember, keep at it and stay motivated.